circuit shown below, find the loop currents. Look at the solution. The first step is identifying the number of loops. There are 2 loops in the circuit. And step 2 is assigning the direction for the loop currents. Let it be I1 and I2 are flowing through loop 1 and 2 in the clockwise direction. Let us assume that as I1 and I2. Now, for suppose if I apply KVL to loop 1, we know that a KVL is nothing but every term in the equation represents a voltage. For suppose you look here, for suppose we are applying KVL to loop 1, what do we get? Minus 8, 2 into I1. But here we don't have a voltage to represent. Straight away a current source is given here. How do you represent voltage across that 1 ampere current source? We can't represent. Then these kind of problems we are supposed to solve using supermesh analysis. For that, the approach is that instead of applying KVL for only loop 1, I'm going to choose a direction like this. Both combined loops at a time, I'm going to apply KVL. Just look at the equation. KVL to loop 1 and 2. So what do we get? Minus 8 plus 2 into I1, because the current flowing through loop 1 is I1 and current flowing through 2 ohms is I1, therefore 2 into I1. And I'm jumping to the next loop. Current flowing through this 2 ohm resistor is I2, so it is going to be 2 into I2. And then the positive terminal is coming first, so it is going to be plus 4 equal to 0. So if we simplify this, what do we get? 2I1 plus 2I2 minus 8 plus 4, we get minus 4. If I take that to the right hand side, I get plus 4. So if we simplify this, we get I1 plus I2 is equal to 2. Name it as equation 1. So we have now 2 unknowns to find out here, I1 and I2, but we have only one equation. So we need one more equation to find out these 2 unknowns. We are going to make use of this particular super mesh branch. So what I'm going to do here is I'm going to apply KCL at this node. If I apply KCL at this node, what do I get? What are all the currents entering here? I1 is entering. And what are all the currents leaving? 1 amperes is leaving and I2 is leaving. Therefore, I get here I1 minus I2 equal to 1. Name it as equation 2. Therefore, now we got 2 equations. So by elimination method, I can solve 1 and 2. So let us solve that. Solve equation 1 and 2. So equation 1 implies I1 plus I2 equal to 2. Equation 2 implies I1 minus I2 equal to 1. Therefore, I can cancel out plus I2 and minus I2. What do we get? 2I1 equal to 3, which implies I1 equal to 3 by 2, 1.5 ampere. Now, substitute I1 value in equation 1. What do we get? I1 is 1.5 plus I2 equal to 2. Therefore, your I2 is going to be 2 minus 1.5. It is 0.5 ampere. So this is how we are supposed to solve super mesh problems.